Greetings, Earthlings. Welcome back to the Art of Math. Today we're going to continue with another application having to do with economics. So in today's example, this can apply to any business, anything whatsoever. You can be making shoes, staplers, bicycles, whatever. In our example, we have Peter, who's a pizza store owner. There's my beautiful artwork of him making a pizza, and it smells good. Don't make jokes. Okay. And then you have Pedro the Pizza Goblin. And as you can tell, he's a little mesmerized by the pizza. All right. So, in a perfect world, Peter could charge millions of dollars for every pizza, and people would just keep buying the pizza because they love pizza. In reality, so let's go a little bit into that. So, in other words, how do you determine how much money you're going to make? Well, there's how many pizzas did he sell and how much did he charge per pizza. So, this will be our quantity equation. In other words, if he charges a lot of money per pizza, fewer people will buy it. So that's what this curve represents. If the pizza is free, so if the price is 0, I just made up these numbers. So if you plug in P equals 0, then he's going to sell 50,001 pizza. So he's going to sell a ton of pizzas because everybody's like, hey, it's free, I want a pizza. Maybe not everybody, but a lot of demand. Now let's say he's like, I'm going to charge you guys $1. All right, well, subtract off 500 times 1. Because that's $1, so 500 fewer people will want it. Now, let's say he charges $100 for the pizza. That's a lot of money for a pizza. So if you plug in 100, 500 times 100 should get you 50,000. So this will get you 1. So this will be a super tiny number. So although he could say, hey, I'm making a lot of money on each pizza, he's only going to get one person buying it. So he's going to make only $100 times 1, or that'll be his total revenue. That's not a lot of money. And you might ask, like, wait, if you charge $100, nobody's going to buy your pizza. Well, maybe there's going to be a Pedro the Pizza Goblin, and this guy's just addicted to pizza, and no matter like how much you charge him, he's still going to want the pizza. But most normal people will not want it. So I just did this as an example. So like, it may not be in reality such a smooth curve. It may be a little like jumpy, but a lot of people say, oh, chicken costs a little less. This is too expensive. I'm out. I'm not buying this. Other people are like, I want pizza today. I don't care if it's $10 or $20. So they're not really going to be sensitive to what you charge them. But that's the exception. So there's not a lot of Pedro the Pizza Goblins running around. All right. So that's your lone pizza superhero over here. Okay. So how does Peter decide what price to charge for his pizza to make the most money? So first of all, let's back up. The profit is determined by the revenue minus the cost. So the revenue is simply P times Q. It's what he charges per pizza times the number of pizzas he sells. That's straightforward. The cost is, well, making pizza is not free. First of all, he had to buy the pizza store. So we'll assume it was $500,000 for all the equipment for all the store. Just run with the numbers. Don't think too much about them. All right, 500K just means 500,000. That's shorthand. And the ingredients, you might be thinking, well, what about the workers? What about the light? There's other factors. This is a toy example. So let's say it costs him $3 for the bread, the cheese, the dough, all that stuff. Okay, so if he chooses to charge P, his profit will be P times Q minus 500,000, because no matter how many pizzas he sells, he still has to pay 500,000 for the store. So this has nothing to do with quantity. And then furthermore, it costs him $3 per pizza, so it's 3 times P. So although he makes money on the pizza, he also sorry, that's not P, that's a Q. For each extra pizza he sells, his costs go up because he has to buy more ingredients. So we can combine these. So it's really just Q times P minus 3 minus 500K. So whatever he charges for the pizza, so let's say he charges $40. Well, that's a lot of money. Let's say he charges $15. He only makes $12 because it's 15 minus 3. All right. Now we don't want the Q because we don't want two variables. So let's replace Q with this. So our profit, we'll just give it a dollar sign. All right. So our dollar sign is going to be 50,001 minus 500p times this p minus 3 minus, and I'll write it out this time, 500,000. All right, this looks messy, but if you were to multiply all this out, you'll notice there's going to be a p squared from these two multiplied. There's going to be a p term from here, a p term from multiplying these, this number term. The point is, this is a quadratic equation. So, I'm not going to solve this. The numbers are ugly. This is just to show you how we would set this up. If you set this up and you want to find, by the way, notice this is a negative, so that's negative 500p times p. Since the p squared term is negative, that means it's an upside down parabola. So, since we want to maximize the profit, we want to find this top point, specifically the height, right? So, again, we're back to finding the vertex of this parabola. How do you do that? Revisit finding the vertex. You could find the axis of symmetry, negative b over 2a. Rearrange this so that it looks like the 8x squared plus bx plus c. Find your axis of symmetry, plug that in, you can complete the square. Either of those will work. So again, review the previous videos. And there you go. So by finding the appropriate price, so this will correspond to a price on your x-axis. So if you pick a certain price, then you will make the most amount of money. If you pick a different price, you'll make a little bit less profit. So there's a sweet spot for this number. So I encourage you guys to try this problem. See if you get a number. You're welcome to use a calculator. I know the numbers are really messy. So see what you guys get. And, you know, I don't know, just think a little further about Pedro the Pizza Goblin and Peter, and let me know in the comments if you guys have any additional thoughts. And one more thing I want to mention. So I'm going to close with the applications with saying there's so many more applications. I couldn't possibly cover all of them. I just wanted to give you guys a nice sense of some different ones. So if you're interested in planetary motion, of how planets rotate around the solar system, other galaxies, quadratic equations are going to come into play. So much more math and physics has it. Water fountains. If you ever wondered, why do water fountains have this shape? That's a parabola. Baseballs. If you throw a baseball, it's shaped like a parabola. Brakes, your car brakes. So if engineers didn't know anything about parabolas, you would be getting into car accidents. Electronics. I'll just leave it at that. Biology. And you could read, I encourage you guys explore more on your own and discover your own applications. And if you have some cool ones that you think I've missed, please let me know in the comments. Alright, see you guys in the next video.